to put lines in slope-intercept form and graph them. So this is more Algebra 1 review. So does anyone remember what slope-intercept form is? Y equals mx plus b. Does anyone remember what those letters stand for? Good. B is the y-intercept, m is the slope. If I can put a line in that form, then it's a lot easier to graph. So that's why we want to be able to put lines in slope-intercept form. So that's the new stuff for the day. So the first one, to get it in slope-intercept form, I have to have y completely by itself. So what would I need to do to the first one to get y completely by itself? Subtract the 3x, right, from both sides. So I get negative 2y equals negative 3x plus 6. That's subtracting 3x from both sides. That's about it. 3x and minus 3x. I put it in front. Would it be wrong if you put it behind the 6? No, it might be a little harder to pick out the m and the b, but it's the same thing. So easy. Questions so far? Now what? Divide by negative 2. I do have to divide every piece by negative 2. So I get 3 divided negative 3 divided by negative 2, which is just 3 over 2. And then 6 divided by negative 2, which is negative 3. Any questions so far? The slope would be 3 over 2. The y-intercept would be negative 3. I can graph it based on that information, can't I? So y-intercept is negative 3. Let's start crossing the y-axis. So I'm going to go down 1, 2, 3 units to the point. Good. Slope is rise over run. I've heard people say you have to stand up before you can walk, something like that. We go up and then over. 3 over 2. So I'm going to go up 1, 2, 3. Right 1, 2. If either one of those were negative, we would either have to go down or left. We'll look at that one of those times. So this is the line. And we could plot more points if you wanted to be more accurate. We could go up 1, 2, 3 over 2 again. It's a little bit. Any questions about that? The next one, slope-intercept form. I need to get the y by itself. This down here. So 3y minus 2 equals 7. So I'm going to add the 2. So 3y equals 9. Divided by 3. So y equals 3. Where's the x? Hey, there's nothing there. Something's weird about it. What's the y-intercept? 3 is the y-intercept. And there's no slope. What does that mean? Well, if you think about it, it says y equals 3. When does y equal 3? Always. So what would that make if I start plotting y equals 3 always? It's a horizontal line, right? So y equals 3 is a horizontal line. The slope is 0. Could I write plus 0x if I really wanted to? I could. It'd be silly, but I could. So the slope of that line is 0. You might want to write that down. The slope of a horizontal line is 0. Any questions about that one? Okay, let's look at the 3x minus 3 equals 3. So I would add a 3. we have zero slope with this one. Slope is rise over run, right? So I can rise on this line, right? I go up 3. How far do I go over? I don't. So would you agree my run would be 0? So type in your calculator 3 over 0, or 1 over 0, 10 over 0, anything over 0. And what does it say? Error. The slope of a vertical line is undefined. Write that down. The slope of a vertical line is undefined. So the red line, I can walk along it, I just don't go any higher, right? So 0 slope. If I walk along the green line, I fall off a cliff. That is undefined. I don't know if that helps you remember that or not. It's somehow you remember. Horizontal line is 0 slope. Vertical line, undefined slope. And last one is already in slope-intercept form. What is the y-intercept? 2, and what is the slope? 7 over 1. There's not a denominator, the 1 is 1. And it's going to be hard for you to graph, but that's okay. 1, 2, 3, 5, 6, 7, 8. This is a distinct line. Up 7 units and over 1 unit.
Do you start from the slope or from the zero?
From the y-intercept.
Oh,
Let's try again. Again, if you just write it down, one couple of big things you need to know: the slope of a horizontal line is 0, and the slope of a vertical line is undefined. Identify the slope and y-intercept and graph the line. So I have 4 lines here. If we can do this, do that. Identify the slope and y-intercept and graph the line. Identify the slope, find the y-intercept, and graph the line. Just on your homework, there's a grid, but for notes, you'll just have to. slope. The slope's just the number. And what is the y-intercept? So your homework will ask those questions. They'll say m equals blank and c equals blank. Okay. And then graph 1. Well, if I know the y-intercept is -2, and the slope is 3, what's on the bottom of that 3? There's over 1, right? So I'm going to go rise 3, run 1. 1, 2, 3, run 1. What do I need to do to this one? Add 6. I need to get the y by itself, right? So I can add the 6x to the other side. Am I doing that? And then what? Divide by the -3. Remember to divide every piece by that -3. So the slope is -2. And the y-intercept is negative. Y-intercept -3. I'll plot that. The slope is -2. -2 over what? 1. Since it's -2 over 1, I'm going to go -2 down. Right? So I'm going to go 2 units down and then 1 unit to the right. So when I see a negative direction, it's either down or left. Now why do I keep saying or, down or left? Well, anyone, it's probably not on this particular problem, but could you have written this as 2 over -1? Is that the same thing? It is, right? 2 divided by -1 is -2, and -2 divided by +1 is -2. So you could also have gone up to left 1. The reason I'm mentioning this is some of you on your homework may get a negative in a different place on the slope. Does it create the same line? Yeah. So either way is wonderful. So either one of those is the same thing. You can either go down 2 and right 1, or you can go up 2 and left 1. Did that make sense to everyone? How that's the same thing? Same thing as far as the slope is. Add 1. As soon as I notice that this is an x equals line, I have to go, whoops, that's weird. That's a little different. What does an x equals line look like? Vertical line, right? X equals the vertical line. Because x is always the same number. What is the slope of a vertical line? Undefined. Are those different things? Yes. So make sure that vertical line is undefined, horizontal line is. And what is the y-intercept? Does it cross the y-axis? Most vertical lines won't cross the y-axis. The only one that would be the line x equals 0. The last one, chapter 7. Divide by 2, so I get y equals -5. This one is a little easier than the x equals to figure out if you forget it. You've got to memorize what happens on the x equals line. This one you could probably figure it out just based horizontal or y equals what it looks like. It's horizontal. Slope is 0, y-intercept of -5. Any questions about that? This is all your homework efforts tonight. We're going to get a little head start on tomorrow. Tomorrow we're going to start factoring. So you'll know that there's quite a bit to that. How many of you spent a lot of time on factoring last year? Yeah? Okay. Maybe not for everyone. Okay. So you've got a worksheet that I'll give you just tonight. But we're going to go ahead and start factoring a little bit. The first thing I want to know is if you know what a greatest common factor is. Yeah. Problems on this worksheet. It looks like more than it is because of the graphs being graph problem. The first few should take as long as you don't need to actually arrange them. The back ones will take a little bit longer because you still have to go by it. And before I go on to this, how do we feel about graphing linear equations? Did that come back quick? Yeah. This is algebra 1 since you learned that probably. We will do some graphing. We'll start with quadratics. We'll graph some exponentials, logarithms, but in their own chapters. First of all, if I'm asking you to find a greatest common factor, let's talk about what a factor is. What is a factor? Something that goes into a number that multiplies into a number. So if I'm talking about the number 6, what are the factors of 6? 1 and 6, 2 and 3, those are factors of 6. Now let's talk about what it means to be common. What do you think it means to be common? The same. So two different things having the same factor, right? Common factor. The greatest common factor is the factor that's the biggest that they have in common. Does that make sense? So to start this one, I'm going to write this out in factor format for a second. 3 times x is what I've got on the left. Does 9 have anything in common with 3? It's 3, right? Yeah. And so 3 times x times y, and y. Of course, we won't always write it out that long. But. So do they have anything in common? They have a 3 and an x in common. That is the greatest common factor. So 3x would be the greatest common factor. The first factoring technique we will learn how to do is factoring out a greatest common factor. So you have to be able to identify what it is so that we can factor it out. Questions about that so far? So what we're going to be looking at is factoring, first of all, is writing something as a multiplication problem. Something that's not a multiplication problem and turning it into a multiplication problem. Like 6 being 2 times 3. We factored 6. Well, we can also factor polynomials or expressions that aren't just numbers. Like 6y minus 3. That's not a multiplication problem. But wouldn't you agree I could write it as 3 times 2y minus 1? Those are the same thing. Undistributed. I took that 3 6 and a 3. So that's what it means to factor. So take something that's addition or subtraction, turn it into multiplication. There is a reason we want to do that. It's not just for fun. When we get into equation solving, anything that's not linear, to solve those equations, we need it in factored format. We'll talk about why. So, today we're only going to do greatest common factor, just taking out the greatest common factor. Tomorrow we'll look at some trinomials and we'll go from there. So, the greatest common factor is the factor, so something that multiplies in to all of the pieces. It's the greatest one that goes into all three. So when I look for greatest common factor, I'm going to look at it in separate pieces. First, I'm going to look at the numbers to see if the numbers have any common factors. Then I'll look at the letters. So I'm going to start with 3, 9, and 15. Is there a greatest common factor? 3. Everyone agree 3 goes into 3, 3 goes into 9, and then 3 goes into 15. 3 is a common factor. What about x's? Do they have any x's? Do they all 3 have the same, what do they have? You're right. They all 3 have how many x's? 1. Why can't I do 2? But 15 doesn't have 2. Do they have y's in common? No.
Doesn't a 9 have 2?
It does, but they don't all have 2. So for common, they have to all have it. So they all have a 3. They all have 1x. Do they all have a y? No. So my greatest common factors are x. That's it. If that's the question, you stop there. If it just says, what is the greatest common factor? That's it. Some of them will say, factor out the greatest common factor. So, to do that, I'm going to rewrite this as a multiplication problem with the 3x factored out. Would you agree that what we are doing is the opposite of multiplying it in? What's the opposite of multiplication? Division. So in each piece, I'm going to divide the 3x out to make it equivalent. So what would happen if I divide 3x out of this piece? What would be left? Just a y squared? Everyone agree? Questions? What would be left if I divided 3x out of this? So let's start with the 3. 9 divided by 3 is 3, right? What's x squared divided by x? And y's just there, so just what's 15 divided by 3? And what happens to the x? Divide that, right? X divided by x is just 1. How can I know if I'm right? Multiply it back in, right? Because I just undid multiplying it in, so just check. 3x times y squared, does that give me 3xy squared? 3x times negative 3xy, does that give me negative 9x squared y? And 3x times 5, does that give me 15x? Good job. Try this. Find the GCF and factor it out. Now that we see this, did we all do this last year?
Yes.
No? Okay. Is it making sense? Are there any numbers in common? numbers, not letters? Are there any numbers in common? Why not? I hear some of you saying no. Why not? The last one just doesn't have a number with it, right? It just is 1x cubed. So it doesn't have a 2. So the 2 was the thought, right? But the last one doesn't have it. So if everyone doesn't have it, this is like church league softball. Everybody gets to play, right? So if they're not getting to play, then we don't get to do it. So 8, 2, and 1 have no common factors. What about x's? They all have 1. So that's my greatest common factor. If I divided x out, what would be left on the 8x squared part? 8x minus 2 minus, if I have x cubed and I divide out an x, what's left? X squared. Why x squared? There were 3 of them, and I divided 1 out, right? So there would be 2 left. Check it. Did it work? Okay, last one. 12, 3, 15, and 6. Do they have any numbers in common? 3. What about the s's? S squared? Does everyone agree that there are at least 2 s's? What did you look for to find that? The one that has the smallest exponent, because remember everyone gets to play, so if they don't have enough to play, then we can't put that in. So s squared, and then t. There's 1. If I divide 12 by 3, I get 4. S to the 4th divided by s squared is s squared. T squared divided by t is t. So my first term would be 4 s squared. Second term, 3's divide completely out. The s squareds divide completely out. And so what's left? T. So there's 5 up here, and I took 1 out. 4. Does that make sense?
No mistake, it wrote like T.
Like in front of this?
Divided by 3.
Perfect. You are good. You can do that. 15 divided by 3 is 5. Good. 5s only. Where the t's go? They cancel out. T divided by t goes one way. That was our factor that had the lowest amount of t's, right? So and then 6 divided by 3 is 2. There are 8 s's, and I'm taking out 2 of them, so there are 6 left. And there are 5 t's, and I'm taking out 1 of them. And how can you know if you did it right? Multiply it back in and see if you get the same again. Any questions? Tomorrow, our lesson tomorrow will be factoring out the greatest common factor and trinomials. So we've kind of already gotten the TCF out of the way. Use the last 10 minutes of class to do your homework. 10 minutes left.